Alrighty, guys. And yeah, I do recognize that it's a little confusing today, that it is a 246 day and not the normally scheduled 135 day, and I do believe there was a little bit of confusion on calendars, depending on which calendar you looked at, as to which classes were today, so I do apologize about that. It probably would have been smart for me to send out a reminder yesterday, and I did not think of that, so I'm sorry for that, guys. Also, you probably noticed I'm actually in my physical classroom. I'm hosting one of our senior learning pods here at Orange Glen, which is why I'm wearing a mask. But I do believe you guys can still hear me pretty well, and everything basically will run as it has been for you guys. But you just won't be able to see my beautiful smile anymore because I'll be wearing a mask for the most part, unless my room is empty, which it is not right now. So, anywho, welcome back. I hope you guys had a good weekend, and I hope the asynchronous time was more helpful than hurtful for you guys. I hope your teachers didn't load you up with a bunch of stuff to do over that time and that you got a chance to relax or catch up on things. If that wasn't the case, hopefully that's what spring break does for you. You get a chance to relax and de-stress. So today we're doing section 9.2, test about a population proportion. It's going to be, we're going to have a couple of questions sprinkled in here with our normal kind of like lesson slides. And that's kind of how it's going to work. So if you haven't joined the Desmos activity yet, please do so. If you cannot join the Desmos activity for some reason, please let me know so I can help, or we can come to another way about this. But here we go, and thank you all for checking in. If you're still finishing checking in, that's fine. You can totally continue that. I will take a look at your responses a little bit later. And as we go through this, I'm just going to add screens that you can scroll back and forth between. I'm not going to like only do one screen at a time kind of thing. Just add them all up. So if you have something you're taking notes on, you probably want to have that ready. There'll be a few things that you might want to write down, not a ton. And we're going to get started. All right. And also feel free to follow along on the shared screen or just follow along on your own Desmos screen. That's up to you. So right here, our objectives for section 9.2, test about a population proportion. Right after this section, you should be able to state and check the random 10% in large counts conditions for performing significance test about a population proportion. You should be able to perform a significance test about a population proportion, interpret the power of a test and describe what factors affect the power of a test, and describe the relationship among the probability of a type 1 error, significance level, probability of a type 2 error, and the power of a test. We're basically going to get through half of this today. We'll do the other half when we get back, along with a little bit of review of what Chapter 9 is. All right. So the first thing that comes up, checking conditions. This is always kind of like our first step, you know, when we're going along our 4-step process, which we will continue to use. We'll outline what that is a little bit later when doing a significance test. But once we have our hypotheses, we have to check conditions to see if we can continue with our test. In Chapter 8, we introduce the 3 conditions that should be met before we construct a confidence interval for an unknown population proportion: random, 10% when sampling without replacement, and large counts. These are the same 3 conditions that must be verified before carrying out a significance test. Exact same things to check. So whether we're doing confidence intervals, confidence level, or significance test, same 3 conditions. All right. We got random, 10%, and large counts. All right, so random, the data come from a well-designed random sample or randomized experiment. You're looking to see in the context that they say we randomly sampled, right, something to that effect so that we know it was random. 10%, when sampling without replacement, check that the sample size n is less than or equal to 1/10 of the population size, capital N. All right. And large counts, both n, p sub 0, and p sub 0 is just whatever the null hypothesis parameter is. and n times 1 minus p sub 0 are at least 10. So the number of successes and the number of failures in our sample are both at least 10. Those are the three conditions. Does anyone need a moment to write any of this down in your notes before we move on? All right. All right. So that brings us to the first problem that we're going to do. All right, walking to school. And we'll refer to the same context a little bit later. A recent report claimed that 13% of students typically walk to school. Deanna thinks that the proportion is higher than 0.13 at her large elementary school, so she surveys a random sample of 100 students to find out. Are the conditions for carrying out a significance test met? You need to choose yes or no. Once you've selected yes or no, you'll be asked to explain why you made your selection. That box will pop up after you select yes or no. All right. So, I'll give you all 3 minutes to answer this question, and then we will review and talk about it. If you do have any questions between now and then, please let me know. You see that you guys are writing your explanations here. Most of what I see so far looks really good. Everyone who has made a choice here, which we got 6 out of 9 of you who made a choice between yes or no, and it is correct, yes. The conditions for carrying out a significance test have been met. All right, and then let's look at why. There we go. So if you take a look at the shared screen in Teams, I have the quick breakdown of how the conditions have been met. Although those of you who answered yes, you realize the conditions were met, right? And most of you guys have a really nice explanation as to why. Sample is a random sample, so our random condition has been met. Sample size of 100 is less than 10% of the school's population, and again, that's because we're assuming that this is a large elementary school, as we've been told, and that there's more than 1,000 students on campus. Large counts, 13% of 100 is 13, which is greater than or equal to 10, and 87% of 100, probability of failure, is 87, which is greater than or equal to 10, right? So our large counts condition has been met. Okay. Excuse me. Is there anything I can clarify about checking the conditions? So then we're going to move on. So next, what is a significance test? Right? A significance test uses sample data to measure the strength of evidence against the null hypothesis. Here are some principles that apply to most tests. The test compares a statistic calculated from sample data, right? In this case we'll use p hat, with the value of the parameter stated by the null hypothesis, whatever we're assuming p is equal to. Values of the statistic far from the null parameter value in the direction specified by the alternative hypothesis give evidence against the null hypothesis. All right, so if our statistic lands like far away, so to say, from the null hypothesis parameter, that's evidence that the null hypothesis might not be true. And we measure how far it is away essentially by standardizing, the same as we have in previous things with population. We get it standardized. That gives us a measurement of exactly like kind of how far away it is. And beyond a certain point of distance, right, we say that this is evidence against. So a test statistic measures how far a sample statistic diverges from what we would expect if the null hypothesis were true. In standardized units, that is, test statistic equals statistic minus the parameter divided by the standard deviation of statistic. Kind of the general way that we standardize. Okay. Excuse me. So you would need a moment to write anything down from this screen? Raise your hand, please. So then we get to the Z statistic. All right. Now, when carrying out a significance test about a population, we will use the test statistic of a Z statistic. We call it a Z statistic because it is similar to a Z-score and will be used along with Table A to help find the p-value for our significance test. The Z statistic is Z equals p hat minus p divided by the square root of p sub 0 times 1 minus p sub 0 divided by n. And if we remember, like p hat is our test, it's our sample proportion, p is the parameter, and this square root p0 times 1 minus p0 divided by n, that's our standard error, which we use when we have our sample. Where p hat is the sample proportion, p is the parameter value, and p sub 0 is the null hypothesis parameter value. Typically, p and p sub 0 are the same value. All right, now that we know what the statistic is that we're going to use, we get a rule, kind of a guideline on how to use these things. And I'll move to the next screen because the next screen has the same formula on it. We get the one sample z-test for a proportion. This is our inference method for significance testing for proportions. All right, we have the one sample z-test for a proportion. We're going to choose an SRS of size n from a large population that contains an unknown proportion p of successes. To test the hypothesis h sub 0 such that p equals p sub 0, compute the z statistic, right, z equals p hat minus p times the square, or divided by the square root of p0 times 1 minus p0 divided by n. Right, and be careful with this division. The square root is taking the square root of this entire fraction. So when you put it in your calculator, you might need to put parentheses around that division to make sure that it's all in the square root. Find the p-value by calculating the probability of getting a z statistic this large or larger in the direction specified by the alternative hypothesis h sub a. All right, so if the alternative is saying that we think that the true value is greater than the null hypothesis, right, we're looking at the area under the curve greater than z. If you know where our alternative is that it's less than, we look at the area under the curve less than the value of z we get. If it is two-sided, meaning it could be greater than or less than, it's just not equal to, we get the area under the curve that's greater than the positive value of z and less than the negative value of z. So we end up adding these up. The good thing is, because we're using a standard normal curve, we have symmetry. So if I know the area under the curve that is less than, so to say, I just multiply it by 2 and I have the total area under the curve that is less than and greater than that certain value. All right, so we get to use that symmetry stuff, which is nice. All right. So please raise your hand if you need a moment to write anything down. So that brings us to our next problem. All right, and this refers back to screen 4 with our walking to school problem in our context. And Deanna, the student, or I think it's a student, for her survey, 17 students in the sample said they typically walk to school. Okay, so that is our sample, right? For part A, calculate the test statistic. In part B, find the p-value using table A. There is a link to table A right here if you need to pull up table A. This is actually a link to all the formulas and tables that you'll have available in the AP exam. I do recommend doing your work on paper and then uploading a picture of your work using the upload image option down here in the left corner of the text entry. Or you're more than welcome to type your response into the text box and use the math type stuff. All right, either option is totally fine. All right, and if you have any questions, let me know. I'm gonna give you all some time to work on this problem. Also, actually, before I let you go, to work on that, make sure you know what the null hypothesis and alternative hypothesis are, right? Because we need to know the direction, right? Are we saying P is greater than the null, less than the null, not just not equal to? So look at the original context to see what our alternative is going to be, because that tells us what to do with the Z statistic once we have it using table A. All right, so we're going to talk about this one. I know that some of you may or may not have a chance to finish it. We're going to get through. I'm going to show you guys how to do this, and then we'll move on. All right, so if you want to look at the shared screen in Teams, I'm going to pull up OneNote, and we're going to look at the work that goes with this one, if you'd like to follow along. So for part A, we need to use the Z statistic, right? The one sample Z test. So we get Z equals P hat minus P divided by the square root of P0 times 1 minus P0 divided by N. All right, I have our hypotheses written here as well to kind of illustrate what's going on. And then, so we have the null hypothesis that P equals 0.13. The alternative is P is greater than 0.13 because Deanna believes the proportion is greater than 13%. So that tells us which direction to look at our distribution in our normal distribution graph. The sample proportion is 17 out of 100 or 0.17, and then P is equal to P0, which is 0.13. So I have everything I need to put into my formula now. We get 0.17 minus 0.13 divided by the square root of 0.13 times 0.87 divided by 100, right? And remember, we're taking the square root of this entire operation down here. We end up with 1.19. That is our test statistic. So we're done with part A. It didn't ask us to do anything except find the test statistic. We're now going to use the test statistic in part B, right? We need to find the p-value. The p-value is the probability that Z is greater than 1.19. And again, we get that greater than from the alternative hypothesis saying that we think the true proportion is greater than the null hypothesis, right? So we use the complement rule, right? 1 minus the probability of Z being less than or equal to 1.19, because remember, table A will only give us the proportion less than or equal to a particular Z value, right? It's not going to tell us the proportion greater than. So using table A, we need to use the complement rule, right? And the probability that we find in table A that Z is less than or equal to 1.19, right? We find 1.1 on the right-hand column, or the left-hand column, 0.09, because when we add those two together, we get 1.19 in the top row, and that intersects at 0.883. So we do 1 minus 0.883, we get 0.117, about 11.7% as the p-value. Visually in the distribution, right, 1.19 would be right about here, and this, the proportion of the under the curve that's shaded is about 11.7%. And again, we're looking at that greater than 1.19 mark. Okay. Is there any questions? Is there anything I can clarify? All right. So again, as I've said in the past, table A is not going anywhere. Got to get comfortable with table A, or how to do the same thing using your calculator. Okay. So that is how we do this problem. And at this point, we're done. We were not asked to draw any conclusions. We weren't asked to do anything besides find the test statistic, find the p-value, and we've done that. So now, moving on. We also have two-sided tests. What we just did was a one-sided test, right? We're looking at the alternative of p being greater than p0. Right? The p-value in a one-sided test is the area in one tail of a standard normal distribution, the tail specified by the alternative hypothesis. In a two-sided test, the alternative hypothesis has the form h sub a such that p is not equal to p0. Right? We're saying it's something other than what the null hypothesis is saying. It could be bigger, it could be smaller. That's what we're trying to show. The p-value in such a test is the probability of getting a sample proportion as far as or farther from p0 in either direction than the observed value of p hat. Right. As a result, you have to find the area in both tails of a standard normal distribution to get the value, to get the p-value. Right. And that's what this little graph shows here back on slide 7. Right, we have two tails that we have to consider when we have a two-sided alternative and a two-sided test. Right. Then there's also a link between confidence intervals and two-sided tests. All right. The 95% confidence interval gives an approximate range of p-zeros that would not be rejected by a two-sided test at the alpha equaling 0.05 significance level. Right, meaning everything at our 95% confidence level, if we get a p hat that's in there, then we would end up not rejecting the null hypothesis. If we ended up getting a p hat on either side of our confidence interval, then that would lead us to reject the null hypothesis. Right? That's kind of the connection between these two in a two-sided test, in a two-sided alternative. Right? A two-sided test at a significance level alpha, say alpha equaling 0.05, and it's very common to use alpha equaling 0.05. If they don't tell you what significance level to use, just use 0.05. Right? If the context of the problem doesn't say, interpret the p-value based on a significance level of alpha equaling 0.01 or alpha equaling 0.1, just use 0.05. That's kind of like a default. And a 100 times 1 minus alpha percent confidence interval, 95% confidence interval if alpha equals 0.05, gives similar information about the population parameter, meaning that we get like the range outside of the confidence interval, so everything inside the confidence interval tells us plausible values for the true parameter. Don't get too caught up in this. Really, it's just to make a note of there's a connection between the confidence interval and significance level when you're dealing with two-sided tests. That leads us, now that we have all of our parts, so to say, to kind of put this together in our four-step process for performing a significance test. It's the same four-step process whether you're doing a test of proportions or means. Right, to perform a significance test, we state hypotheses, check conditions, calculate the test statistic and p-value, and draw a conclusion in the context of the problem. The four-step process is ideal for organizing our work. It's kind of one of the nice things about it. It gives us kind of a step-by-step thing to do. So the significance test, a four-step process. First, we will state what hypotheses do you want to test, null hypothesis, alternative hypothesis, and at what significance level. Define any parameters you use, and when they say define parameters, tell us what p means in context. Tell us what mu means in context. Plan, choose the appropriate inference method. In this case, we just have the one to use in this chapter so far, right? The one sample z test for proportion. Check conditions, random, 10%, large counts. Do, if the conditions are met, perform the calculations, compute the test statistic, and find the p-value. Conclude, make a decision about the hypotheses in the context of the problem. In the conclusion, this is where you say because the p-value is greater than alpha equaling 0.05. Right? We fail to reject the null hypothesis, and we do not have evidence for the alternative. Right? Or because the p-value is less than alpha, right? We make our conclusion based on those conditions, but we always have to tie it back to the context of the problem. You cannot just say we reject the null, we have evidence for the alternative without saying what those things are. Right? Is there anything I can clarify? Is there any questions that you have? All right, so we're actually going to stop here for today. And we will pick up with the rest of this lesson after spring break. You're welcome to look through the Desmos activity on your own if you like. Yeah, let's stop this here while I have you guys on the shared screen. Let's take a quick look at the course. All right, obviously we're in the 24th here. It's a 2-4-6 day. Tomorrow is the beginning of spring break. Hooray! All right, you get the whole next week off, no school, and then school resumes April 6th with your 1-3-5 day, and it kind of goes back to that normal schedule. All right. Yeah, so please keep that in mind. Also, all the stuff for chapter 9 besides the assessments are ready. Okay, we have the notes and resources for 9.2 and 9.3 and the practice problems and solutions for 9.2 and 9.3 as well. I highly recommend, depending on how comfortable you are with this content so far, looking at the practice problems for 9.1, because that's kind of the foundation for the chapter here. And you could look at the practice problems and try them in 9.2. You also do have access to, in the calendar here, you'll have access to just the full PowerPoint presentation. That's kind of like normally what I do on the lesson day, like first day I see you guys, which goes through all of the objectives. The Desmos activity will be linked, and I'll provide the solutions to our Desmos problems as well, just for funsies. And the recording will be posted later. So you'll have access to all these resources when you would like to do and see them and all that fun stuff. All right. So that being said, I will see you guys in like 2 weeks, a little over 2 weeks. I hope you guys have a great rest of your day, that you have a wonderful spring break and you get to have some relaxing time, and that you don't get like bombarded with a bunch of stuff to do. And we'll see you guys when you get back. All right, have a wonderful break.